Hi, welcome back to the channel. In this particular problem, we're looking at how to find the rank of a linear transformation. Now, our transformation is from P2R to P2R, which means set of polynomials with at most degree 2. Okay. So our P of X would be of this kind, right? Okay. But first of all, in order to find the rank of a linear transformation, all we need to do is to find a set of bases for P2R and also another set of bases for P2R and find the metrics of transformation related to these two bases. Now, once we do that, then we can find the rank of the transformation based on the rank of the metrics. So to simplify the problem, we just use standard bases for P2R. And standard basis for P2R is basically 1x squared in this particular order. Okay. Now, all we need to do next is to find t of 1, t of x, and t of what? X squared. Now, how do we find this? Remember, this transformation basically says x multiplied by the derivative of that particular polynomial here. Okay. Then plus p of 2. So let's do each of this. Now, t of 1, right, is just going to be x multiplied by what? So x is always there, right? Multiplied by what? Derivative of this of 1, okay? Then we add it to what? So if this is p of x, right, p of x is equal to 1, so we're looking at p of 2, okay? Now, when we simplify this, 1 prime is just is going to be 0. So 0 times x is 0 plus p of 2, because this is a constant polynomial, p of 2 is still 1. P of anything is 1, basically. Okay, so we have 1 as the first one. What about the second one, t of x? Now, p of x, so our p of x is now equal to x. So what we're going to have here is what? It says x times p prime of x. So we have x times what? P prime of x, so that means we are taking derivative of p of x, right, which is derivative of x, plus p of p2, p of 2. Okay, now derivative of x is 1, 1 times x is x here. Now p of 2 is when we put 2 into this, we have 2, right? So this is going to be plus 2. Then finally, we have x times derivative of x squared plus p of what? 2. Now, derivative of x squared is 2x, so 2x times x, we have 2x squared, plus p of 2. Now, if p of x is x squared, remember, p of x is x squared. That means p of 2 is going to be 2 squared, which is 4. Okay, so we have 4 here. Now, it's quite easy. Now, all we need to do is to now write this as a linear combination of the vectors in the basis for what? P2R. So basically, if you look at this is 1, right? 1, we have x plus 2, we have 2x squared plus 4. And this is just basically 1 times, so we write it as a linear combination of the vectors for the basis for P2R. So which is 1 times 1 plus 0 times x plus 0 times x squared. So these are the coefficients that would be accompanying those vectors, because we have only constant here. So the only time we're going to have any coefficient here that's other than 0 is just 1, right? When we have the constant, the one that represents the constant term. Okay, the next one, so we're going to have 2 times 1, right? I'm writing based on what I have on the left-hand side. Then for the coefficient of x is going to be 1, then no coefficient of x squared. Finally, 4 times 1 plus 0 times x, then plus 2 times what? X squared. Okay, now what we need to do next is to write this. So the matrix of transformation would be written, the rows of this would be the first column of this matrix. Then the second row would be the second column. So I'm using the coefficients, right, of these vectors. And finally, I have 4, 0, 2. Okay, so this is the matrix of transformation. Now you need to find the rank of this. Now, what does that mean to find the rank? You need to find the number of linearly independent column vectors or row vectors, right? Now, we don't need to actually So these are the vectors. So for the column vectors, this is what we have. So we need to find the maximum number of days that will be linearly independent, right? The maximum is 3, and the minimum, it can go down to 1, right? So it depends. So when you look at this, how you can quickly know the number of linearly independent rows or columns without actually trying to find out how many of these vectors are linearly independent is this, using the row reduced echelon matrix. So once, the first thing that you need to do is what, reduce this to a row reduced echelon matrix. Now it seems this is already done for us here. All you need to do is to divide row 3 by 2. So you divide row 3 by 2, then you have this. Okay. Now you can see that what, when you look at this, you can see that each row, the next non-zero digit is starting to the right of this first one. So you can see the stairs. So this tells us that what, we have 3 linearly independent vectors in this particular matrix, right? So you can see that the next number is always starting to the right side and just reduced by 1 to the right side of the second row. The third one is just on the third row, and so on and so forth. So basically this is 3, the rank of this matrix of M is 3, okay? Because of after we row reduce it, we see that what we do not have any redundant row. Now, what I mean by redundant row is this. Let's say what you have was this. Let's say this is what you have after reducing this. You can see that what you only have this 2 stairs, right? So only two vectors here will be linearly independent, right? In this particular case, okay. And the rank of this particular matrix would be 2. But you can see here all the 3 stairs were used. So therefore, the rank of this matrix is 3. So that brings us to the end of this video. If you enjoyed this, please give it a thumbs up, and then subscribe to the channel if you haven't done that. If this is your first time, make sure you subscribe to the channel and then press the bell button so that you'll be informed anytime I upload a new video. So I'll see you guys in the next one.